Hey everyone, today we're going to talk about trig identities, a topic that is very different than most math because it involves proving stuff, and that's much more to like something you might have done in geometry. So here are some examples of identity. We're first going to launch into what is an identity because that's what you are all going to be working with. An identity is an equation which is true no matter what you plug in, okay? No matter what you put in for a variable. So you see over here to the right, we've got sine is the reciprocal of cosecant. That's just a definition, right? That's what cosecant is. So no matter what you plug in there, sine of whatever number that is, 35.5, is equal to 1 over cosecant of 35.5. Alright, more interesting one, I believe, is tangent equals sine over cosine. And we've talked about that a little bit. You can actually prove that pretty quickly using SOHCAHTOA. So if opposite over hypotenuse is divided by adjacent over hypotenuse, then you get opposite over adjacent, which is tangent. But yeah, let's talk about what is a proof. Well, proof is just, I want to say proving something, and I don't want to use the word in definition. So it's a demonstration showing that both sides are equal in the sense when we're using trig identities. So we want to prove, for example, this equation right here on the right, we want to prove that no matter what you plug in for x on the left, it's going to equal if you plug in the same number for x on the right. So how do we do that? Well, let's start by remembering, and so we have our example here. We'll start by remembering that secant is the reciprocal of cosine, and so that goes both ways. Secant of theta equals 1 over cosine. You also know that cotangent is the reciprocal of tangent, so you just flip tangent there and you get cosine over sine. So what we're going to do here, and this is one tip, I'm writing these right here. I want you to write them down right below that, okay? The first one is less of a tip and more of a rule you should follow, and I'll give you a very good reason for this in class if you ask me. You should only work on one side when dealing with these equations, all right? So you're going to want to add that tip. Anything in the light blue, add those to the tips box down there, okay? The other thing you'll want to add is another tip is only change everything to sine and cosine, okay? That's a very helpful tip to solve these. So what we're going to do is we're going to look at these two guys, and I'm going to work with the left side, okay? I'm going to change everything on the left side to sine, and to put it in terms of sine and cosine, especially using these definitions that I have up here. So let's change secant to 1 over cosine, and let's change cotangent to cosine over sine. And I just realized that those should be x's, no worries. X and x and x, cool. Yeah, just changing up the variable there. So let's see here, we're multiplying those two. We can divide out cosine over sine, and we're left with just 1 over sine. Well, what do you know? 1 over sine, that's the definition of cosecant. So we have cosecant on the left and cosecant on the right. Notice we only used the left side when proving this. We only changed things on the left side to make it equal to what's on the right side. And the other tip we also used was changing everything to sine and cosine. So like I said before, go ahead and put these guys in you should have already had those guys in the tips. One other thing I want to add that I also did but didn't tell you about was, you notice we used the left side. The reason I chose the left side was because it was the more complicated side. I think it's much easier to make complicated stuff simple than to start with simple stuff and make it complicated, okay? And you're welcome to try that, but yeah, I think starting with the complex side, or whatever looks more complex at the beginning, will generally be a good strategy. Alright, let's try proving another identity here. Oh, and so, by the way, I want to put in our toolbox, you already know tangent is sine over cosine, so let's go ahead and add that. Let's also add that cotangent, since it's the reciprocal, let's put that it's cosine over sine. In this toolbox here, we're going to be adding stuff as we go through this unit. Into this toolbox, I will let you guys use just a toolbox like that. I'll be putting one of these on your quiz. Okay, so it's a good thing to have anytime you're doing problems or practice problems or homework problems or whatnot. is this toolbox. So let's try the next problem. Actually, I want you to try this one on your own. It should be very similar to the one we just did. Pause the video and do that. Alright, now that you've gotten that one done, or at least attempted, I want to point out one more important identity that I can't remember if we talked about yet or not, but it would still be helpful. You remember on the unit circle, all those triangles were had radius 1, so the circle had radius 1, so all the triangles' hypotenuse were 1. And if you look at the sides, they were the horizontal direction was our x, and the vertical direction was our y. Well, if you remember, y is equal to the sine of theta, if we mark that angle theta, and x is equal to cosine of theta. What that means is that if we use the Pythagorean theorem, sine squared plus cosine squared equals 1, and that is always true. Go ahead and try it. Plug in any number, pick like 15 or something like that. You can do sine squared of 15. Rather, in your calculator, you want to type sine of 15 and then square it. And if you add that to cosine of 15 and square all of the cosine, then you get 1 exactly, even if the two numbers are crazy decimals that keep on going forever. Cool. So this, I want you to throw in your toolbox there. We're going to use it a few times down here. All right. So let's try this next one. What I'm going to do is I'm going to use our first tip, or one of our first tips, of changing everything to sine and cosine. This is probably the most handy tip that I'll share with you. I'm also going to use the left side there because it looks like the more complicated side to me. So, change tangent to sine over cosine. Everything else is already in terms of sine and cosine. Now, we have a fraction, right? I want to combine these two fractions. To combine them, we need a common denominator. So I'm going to make that on the right. I'm going to multiply by 1, and it looks like cosine of x over sine of x, but it's just 1. So we get sine squared of x over cosine of x plus cosine squared of x over cosine of x, and when you add those fractions, you get what I wrote down right there. Since the denominator is the same, you get cosine of x in the denominator. And if you look at the top, sine squared of x plus cosine squared of x, we just showed up there that it's equal to 1, so we get 1 over cosine of x, which happens to be secant of x. Pretty cool. So another tip, we put a little check there. Another tip is that when you see two fractions, combining fractions or turning them into fractions, turning the side into fractions and adding it is a good way of making two things. You see how we have two terms over there become one term. All right. Another tip, and so yeah, don't write these down here. Write them up in your on the other side in your tips box. Okay. Another thing is, let's say you're not sure whether you can do something or not. You should answer, can I do this? You should answer that question with regular numbers. Let me show you what I mean. So let's say you were really uncomfortable with what I just did and some of that, like multiplying by cosine of x over cosine of x. What I'd like for you to do real fast, if you didn't understand all those steps in this process right here, I want you to add 3/5 and 1/5. Not using your calculator, just add it the way you know how to add fractions. And in doing that, I think you will see how we got some of these steps. Okay. The other thing you do is, if you're not sure something will work, replace all those sines, cosines, and all that stuff. Just replace that with numbers and see if you are allowed to do that. See if they're still equal in the end. And as long as you're smart about picking what numbers, then yeah, you can test out anything using simpler numbers. One of the things that always trips up students here is students get overwhelmed with all the letters. It really is just a fancy way of saying numbers. Okay. Or just picking simple variables. I want you to go ahead and try this one on the right here. Do this one because it's very similar to the one we just did. And go ahead and pause the video and press play when you're done. So hopefully you finished that one. For this next one, I'm going to show you guys another little trick. Is factoring. Okay. Once again, don't be overwhelmed by the confusing letters and where that come from, what happened there. Just pretend you had x minus x times y squared, and you can see, oh, well, you just factor the x out. Okay, that's our cosine of x that we took out. If you unfactor it, aka distribute it, then you'll see that what we get is what we started with. So that's just a quick check. Before I go any further, I just want to think about something. I know that 1 equals sine squared plus cosine squared of x. If I just rearranged this, let's say I subtracted sine from both sides, I could get 1 minus sine squared equals cosine squared, which is really nifty because that's kind of the direction I want to go, right? You guys see the 1 minus sine squared of x in there. But there's one tiny problem. We're not allowed to just move this stuff around, okay? Maybe later, remember, because you're not allowed to use both sides of the equation, maybe later we could add that thing I underlined to our toolbox if once we prove it, and we'll hopefully do that. Remind me in class we can do that. But we can't just move stuff around arbitrarily. However, this does help us understand and get closer to our answer. So I'm going to do something funny here, okay? You see the 1 there. I'm going to replace the 1 in the equation with a very funny looking one. Sine squared of x plus cosine squared of x. So if 1 equals cosine squared of x plus sine squared of x, now check it out. Sine squared of x plus sine squared of, or minus sine squared of x equals 0. And those two guys subtract out. All we're left with is cosine squared of x inside that parentheses. And you guys know that cosine of x times cosine squared of x becomes cosine cubed of x, and therefore we get both sides are equal. Pretty nifty little trick, huh? Go ahead and try the same thing on the right there. And that reminds me of one other tip I want you to write down, so don't put this in your tips box. Factoring can make problems a lot easier. Okay, this problem up here is definitely doable without factoring, but you see the factoring brought it down to like 2 steps and then you're done. So keep an eye out for factoring, and that's always good. Alright, try this problem, and then we will, once you're done, play the video again and we'll do these last problems. Alright, hopefully you got that one correct as well. For this one, I'm going to go back to our good old strategy of changing everything to sine and cosine, and I'm going to pick the right side to start because I think it looks a little more complex. I'm going to show you how to start from the left in just a second if you think that one looks more complex, but I really like being able to change everything to sine and cosine. And so I'm going to start with the right. So we know secant's 1 over cosine of theta, and tangent is sine over cosine. Check it out, we already have a common denominator, so we can combine, make it one fraction. When we make it one fraction, we realize, oh, look, we're done. The top is 1 plus sine of theta, and the bottom is cosine of theta. Awesome. So I just want to show you guys real quick that there's more than one way to do this problem. Let's put this dashed line, so this is a different way to do it. So now we're starting from the left, and what I'm going to do is I'm going to separate fractions. Personally, I prefer combining fractions to separating them, so that's why I like starting on the right, but some people like this way of starting on the left better because it's already using sine and cosine, and you can kind of already see where we're going to split the fraction. So we split it up into 1 over cosine plus sine over cosine, and we know that 1 over cosine is secant and sine over cosine is tangent. And so there we go. We've proved that those two sides are equal. That's an identity. Alright, here's what I want you to do. Do this one on the right now, and when you finish, congrats, you've done all these problems. We will get to practicing a lot more of these in the future, so I really, really encourage you to try these on the right, all those ones on the right, before coming to class, okay? Thanks for watching. You can high-five me right there.